Okay, for our third example here in 2-2, we want to talk about the zeros of a polynomial. And so one really helpful thing that we're going to learn here is that a function has at most n real zeros. So what that's saying is that if we have x to the fourth, we have 4 possible zeros. Doesn't mean that we have 4, but that 4 is the most we could have. Sorry, zeros doesn't have an extra E in here, does it? All right, if we had x to the sixth, the most zeros we could have would be 6 zeros. And then the next thing we say here is that we have n minus 1 turning points. And a turning point is just when our graph changes from going up to going down, or from going down to going up. This graph that I've drawn here has 1, 2 turning points. So if we have a graph degree 4, a function degree 4, where the biggest exponent we can find is 4, the most turning points we could have would be 3 turning points, 1 less than the degree. If it's x to the sixth, the most we could have would be 5 turns in our graph. Doesn't mean we have it. We might have 0 turns, but we're definitely not going to have 6 or 7 or 8. It has to be 5 or fewer. All right, so a couple rules here that we're going to go with on our zeros. Remember, 0 is where our graph crosses the x-axis. So if we have x equals a, then a is the 0 of the function. X equals a is also a solution of this equation. That's why we make y equal to 0, or f of x equal to 0. If we're able to factor at any point, then the a is also going to be an x-intercept, otherwise known as a 0. All right? Now, one thing that we want to talk about is multiplicity. Multiple zeros coming from a single factor. So if we have a factor, x minus a to the k, something like this, x minus 5, let's call it squared. All right? What we have here is a double 0. Our graph is going to go through 1, 2, 3, 4, 5 right here. Probably does something just like that, where we're touching at positive 5, but it actually counts as 2 zeros. So it'll have a multiplicity of 2 right there. And that's what this is saying here. If our exponent, k, is even, then the graph touches the x-axis. If it's odd, then it's going to cross it, but it'll still count as more than 1 0. So that's how you could have something like x to the fourth, but only have 2 zeros, where 4 is the most zeros that we could have, but we could have fewer because some of the zeros are going to be doubled up with multiplicities more than 1. Let's see if that makes sense trying a problem here. So f of x equals negative 2x to the fourth plus 2x squared. Let's find all the real zeros and the number of turning points. So my degree is 4. Biggest exponent we can find is 4. That means that possibly we have 4 zeros. And possibly we have 3 turning points, 1 less than 4. But we don't necessarily have all those things. Let's go and find out what we do have. Negative 2x to the fourth plus 2x squared. Let's go ahead and factor what we can. We can pull a negative 2x squared out of this. We'll be left with x squared minus 2. Remember to distribute your negative in there. And so what we'll have at this point is 2 parts. If we solve for the zeros, we'll say that 0 equals negative 2x squared for the first part here. And we'll also say 0 equals x squared minus 2. If we were to solve this, 0 equals x. If we were to solve this, 2 equals x squared. So x equals the square root of 2, which is plus or minus. Let's go ahead and count our zeros. From the square root of 2, we have 1, 2, 3 zeros, but we could have had 4. What happened to our extra 0? Well, what happened is that the 0 of 0, x equals 0, this is the origin, is actually a double 0 because it's 2x squared. So what we're going to say is this is a multiplicity of 2. So at x equals 0, we have a multiplicity of 2. How many turning points are we going to have in this problem? Well, if we have 3 zeros, we're going to have 2 turning points. Okay? So that's what we will have. Let me go ahead and really quickly switch over to the graphing calculator. And I'm going to pause the video for a second to enter in the equation. And what I'm going to do is bring up the graph. I think you should probably do the same thing. Go ahead and punch this into your graphing calculator. And let's take a look and really investigate what this graph looks like. Okay, so I've got my graph, my function written in here, negative 2x to the 4th plus 2x squared. I went to my window and reset to negative 10 to 10 and negative 10 to 10 for my x's and my y's. Go ahead and graph it, and it looks something like this. Just looks like a normal parabola. But we know here that we have at least 3 zeros. Not at least, exactly 3 zeros. At 0 and at plus or minus square root of 2. So we know that we're really not just touching the x-axis once, but 3 times. So we're going to need to zoom in really to see that. So I'm going to do a box zoom. And I really want to check out what's going on close in here at the origin. So let me do my rectangle tight in here at the origin. Really investigate what's going on. So now we can see, there we go. We have our 0 right here. This is negative square root of 2. We have a 0 at 0 with multiplicity 2. That's the touching the 0. And then over here at positive square root of 2. How many times did we turn? Once, twice, 3 times. So I take back what I said before. I was wrong. We got to look at the graph. It does turn 3 times, which is possible because the degree is 4. So this is an example of a problem where you really need to combine using the graphing calculator and using your algebra skills to really get in and find the answer. So let's go ahead and flip back here to our problem. And go ahead and try problem 35 for A, B, and C. Solve all those parts. Alright, if you're ready to go, let's try this. Find all the real zeros of the polynomial function. So for this one, 2 possible zeros. Let's go ahead and solve for them. Plug in 0 for f of x. Get x by itself. And so we're going to say plus or minus 6 equals x. 6 is the square root of 36. So we do have 2 zeros here. Let's talk about the multiplicity of each 0. On this, positive 6 has a multiplicity of 1, and so does negative 6, because each one is just equal to x to the first power. Alright, the number of turning points on this graph, well, if we have a degree of 2, then the most turning points we could have is 1, and that's how many turning points we're going to have. So let's go ahead and flip over to our graphing calculator for part C to see what the graph of this is going to look like. Alright, let me clear off here and retype it in. We've got x squared minus 36. I'm going to reset my window because I was zoomed in before to negative 10 to 10 and negative 10 to 10. Hit graph, and whoa, it goes way down there, but look at that, there's negative 6 and there's positive 6. I would definitely need to zoom out in my y's to see the whole thing. And there you have it.